So this is question 2 at the bottom of page 2. The potential energy for the climber is now 30,000 joules. How high above the ground is the climber? So we still have the same mass for the climber from the previous section. The mass for the climber was still 65 kilograms. And we're wanting to find the height now. That's what we're trying to figure out. So I'm going to use that formula for potential energy. That formula for potential energy is mass times gravity times height. And I just need to plug the right stuff in the right places. So I'm going to put 30,000 joules for my potential energy. And I know my mass is 65 kilograms. And that's right because it's the standard unit for mass is kilograms, so we're okay. And if you've already got this written down, you guys go ahead and work on your stuff. You don't have to wait on me. Gravity was that 10 meters per second squared. Okay, and we're trying to figure out the height. So if I'm trying to solve for h, let me go ahead and simplify this part. What's 65 times 10? Good, it's 650. So we're gonna have 650, this will be kilograms times meters per second squared. And then I'm gonna drop down my 30,000 joules, and I'm gonna drop down my times h. Okay, I'm trying to solve for h. That's the variable that I'm trying to figure out. What's keeping h from being by itself? The 650, good. How do I undo multiplying by 650? Divide by 650, okay? So I'm gonna divide both sides by 650. And I really don't wanna have to write out those units again. I'm gonna be lazy and just write the number. Okay, these things undo each other. And I'm left with my height equals, and I type this in, 30,000 divided by 650. What is it? 46.2. Okay, so we get 46.2, and that's height. So if we've done everything right, the units for that should be meters, because that's our standard units. Good. So here where it asks for the height, now we know what it is. It's that 46.2. Okay, so that's the example 2 on the bottom of page 2. Okay, what I did is first period, I went through some of the problems and recorded it and put it on YouTube already, okay? That will help you tomorrow, and I'll try to do the other problems with you guys then, and that way, between the 2 videos, you'll have something that shows you how to do it no matter what if you get stuck, okay? So I'm gonna skip the first few problems of the example problems on the next page in just a second, and I'm gonna work on the other problems so that between the 2 videos, you'll always have something you can reference then, okay? Okay. Does anyone still need this one up? Okay, fantastic. So we're gonna flip to page 3 if you're following along. If you already know what you're doing though, feel free to work without me, okay? Okay, I'm gonna start on number 2 on page 3 because I did number 1 on the other video, okay? The instructions at the top though, they say for kinetic energy practice, they say solve each problem below using KE equals 1/2 mv squared. Show all of your work. I am big on showing your work. If you just miraculously get the answer, that's not acceptable, okay? Remember, I was a math teacher before this, so if you don't show your work, I'm not gonna have any clue what you did to get that answer. So you at least need to have some intermediate steps in there, okay? Okay, so I'm gonna do question 2 on the bottom of page 3, or middle of page 3. It says a 35 kilogram child. That's gonna be my mass, right? Is that us? That's not us, right? Okay, cool. That's gonna be my mass, is 35 kilograms, okay? Is sledding down a hill. What is the kinetic energy of the child if they reach a speed of 2.5 meters per second? So that's my velocity, is 2.5 meters per second. And we're trying to find the kinetic energy. That's what we're asked to find. I'm gonna put like a little squiggle here, that way you know that's not running it together with the formula. Okay, so this is what I've got. I was given 35 kilograms as the mass. Oh my gosh. Okay, there we go. 2.5 meters per second is my velocity, and I'm trying to find the kinetic energy. I know the kinetic energy formula is 1/2 mv squared, so I just have to put the right stuff in the right places. So kinetic energy is going to be 1/2, what's my mass again?
30.
Good, 35 kilograms. And my velocity is good. So you just have to type this in your calculator. I hardcore struggled with typing things in, right? Last period, it was rough. So I'll try to type it in and not mess it up this time. We'll see how that goes. Okay, I'll use my phone calculator. You guys will have to use a real calculator because you can't have your phones. Oh, did you already do it? Okay, cool. Oh, did you do it in your head?
No, I didn't do it.
Okay. And what did you get as your answer?
109,375.
Okay. Don't be offended. I'm going to type it in one more time just to check, but I bet you're right. Okay, times 35 times. If your calculator doesn't have the squared button, you can always just multiply it by itself twice. But if you rotate your calculator over, it has a squared button there. Yeah, you're right. This is the same thing you said, right? It's 109.375. I'm just gonna round that. So here, I'm gonna come over here. So my kinetic energy was 109.375. That's like 109.4. Okay, what's the units for energy? What's my units gonna be? Joules, good. J for joules. Okay, fantastic. Okay, let's do another one. A bowling ball is traveling 2.5 meters per second. If anyone else wants a calculator, I've got those. I've got the fancy graphic ones there too, okay? 2.5 meters per second. So what is 2.5 meters per second a measure of? Good, that's my velocity. So I'm gonna put that next to V, 2.5 meters per second. Okay, are you guys either working on this independently or following along? Yeah, will you wake him up, please? Okay, that's my velocity. Thank you. Okay, and then it says if the bowling ball has 23.4 joules of kinetic energy, so I'm gonna put that as my KE is 23.4 joules. What is the ball's mass? The answer is 7.49 kilograms. Show how to get this. Oh, thanks. Yep, you're right, 7.49 kilograms. So we have to show our work. Okay, so we're solving for mass. So I'm gonna put, if my formula is kinetic energy equals 1/2 mv squared, and I'm trying to solve for mass, I need to plug in kinetic energy and velocity. What was my kinetic energy? Good. I'm gonna keep 1/2. I'm trying to solve for m. And what was my velocity? Good, 2.5 meters per second. And I'm gonna have to square that quantity. I put the parentheses around it to remind myself that not just the 2.5 gets squared, but also the units get squared. Okay, and now I'm gonna simplify this. So I'm gonna go ahead and type into my calculator everything except for the m on the right. I'm gonna do 1/2 times 2.5 squared. Okay, if you don't wanna do it that way and you just wanna divide both sides by the 1/2 times 2.5 squared and then type it all in at once onto Desmos, you can do it that way too. Okay, so if I'm typing this in on the right, I'm just gonna do 1/2, which is 0.5 times 2.5 squared. Did I do that right? 3.125? Okay. So I now have, you could probably just teach this class for me. You're pretty good with the math stuff. So I end up with 3.125 times m, right? I'm gonna use parentheses because I get my decimal points mixed up with my time signs sometimes. So I just simplified these two things and went ahead and put them all together. Now, how do I undo multiplying by 3.125? Good, so I'm just gonna divide both sides by 3.125. Okay, those undo each other on the right. So I'm left with mass by itself and I type this in, 23.4 divided by 3.125. What did you get when you did that? Okay. I'm gonna check that with mine. That isn't what you just said, right? Did I type something in wrong? Let me type it in one time.
That's 7.488.
Okay, that's what I just got too. Let me, oh, you can't, I was gonna say, let me type it in one more time because I might have made a mistake too. You guys know I make mistakes like it's my job. Like right there. Okay. 23.4 divided by 3.125. Yeah, I got the same thing. Okay. So we get mass is 7.488. I'm just going to round that to 7.5. We get that mass is 7.5. And what's my units for mass? Mass units should be kilograms for this. Or yeah, you could do 7.49 because it doesn't say what to round to. Oh yeah, they gave it a 7.49. So they rounded to the nearest hundredth. That's fine too. I can switch my calculator, sorry. Okay, so that was number 3 at the bottom half of page 3. 3A anyways. What did I do with my coffee? Oh, there it is. Okay. It's hot in here. I'm sorry, you guys. The only thing worse than having boring work is being hot and doing boring work. Sorry. It's like whenever my church used to get hot as a kid, I would pass out. Okay. 3B. If you were to double the mass of the ball, what will its kinetic energy be? So if we double the mass,
0.1001.
the mass before was 7.49. What's up? The mass before was 7.49, so let's double that. What's our new mass gonna be?
56.1001.
Our new mass, if we double the mass,
Yeah, so I got it.
what did you say it was?
56.1001.
But the mass was 7.49 before.
Yeah.
Oh, are you just saying the answer?
Yeah.
Oh, okay. I'm going to show the work really quick. Okay. So when you double the mass, we're going to double 7.49 or 7.49. So what is twice of 7.49? That's 14.98, right? Okay, so our new mass is 14.98. Okay, we're still gonna have the same velocity, right? They didn't say we were changing the velocity. So the velocity is still gonna be 2.5 meters per second. Now we're gonna use those new numbers and do the same stuff. We're gonna do the same formula, okay? So I'm still gonna use my formula for kinetic energy. It's just instead of solving for mass, I'm gonna solve for kinetic energy now. So kinetic energy is 1/2 times, the mass is 14.98 kilograms, times my velocity, which we said they didn't tell us to change, so it's still 2.5 meters per second, and velocity is gonna be squared. So we're just gonna type all that in, and that will tell us our, ooh, sorry, got overly excited there. That'll tell us our kinetic energy. So 1/2 is 0.5 times 14.98 times 2.5. Times 2.5 again, right? Because it's 2.5 squared. 46.8, that is what you said, right?
No.
Before?
I realized what I did wrong though.
Oh, well, okay, good.
I doubled the mass wrong.
Oh, instead of, okay.
Instead of adding, I multiplied them together.
Okay, so you 15 times the mass. Okay. That's okay. At least you caught it. I'm just going to round that to 46.8. And the units for kinetic energy should be joules. Okay, so before, when the mass was 7.49, our kinetic energy was 23.4 joules. When we double the mass, then the kinetic energy is now double that as well, right? So what happens when you double the mass? Your kinetic energy will also double. They have a 1-to-1 relationship there. Cool. What time does the bell ring? Okay. Okay. I might pause for number 4 and do one on the back side because they're a little different to make sure we have time to go through 1 or 2 on the back, okay? So there might end up being 3 videos posted instead of 2, or I might not go through the very last problem. You might have to figure that one out on your own, okay? Anyone still need this up? Okay, so I'm gonna do one off of page 4. Hey, are you guys with me? I don't want to say people's names because it's on a recording, but please make sure you're with me, okay? Okay, so I'm going to do some on the back, the very last page, page 4. That way you guys can have help working through a few different types. Like I said, the other ones I have recorded already, so you can look at it tomorrow and figure out the ones that I skipped if you need help with them. So I'm on the very back page, page 4, and I'm going to do number 3 with you really quick. That way you can get a different kind. So page 3 was the kinetic energy problems. Page 4 is our potential energy problem. So it's a different formula. Our formula that we're going to use on page 4 for potential energy is going to be that mass times gravity times height. That's that potential energy formula that we're going to use on the back page, page 4. I'm doing number 3 with you. It says, a science student holds a 55-gram egg. Okay, automatically I see a problem with this. What's the problem? Anyone see it? 55-gram egg.
Not in the right unit.
It's not in the right unit. So they gave us 55 grams. We need to change that into kilograms, right? So if there's 1,000 grams in a kilogram, if there's 1,000 grams in a kilogram, and I need those units in kilograms, I like to fence post it. You guys, I showed you how I fence post stuff. I'm going to change that by saying 1 kilogram is 1,000 grams. Well, if 1 kilogram is 1,000 grams, if I do 55 divided by 1,000, that'll get it into kilograms. So 55 divided by 1,000, that's going to move the decimal place left 3. So that will be 0.055 kilograms. Sorry, I didn't leave a lot of room there. Okay, 0.055 kilograms. That's going to be the mass that I use because remember, the units have to be in kilograms for mass. I'm going to scooch this formula over a little bit. Will one of you guys let them in, please and thank you? Thank you so much. I really appreciate it. Okay. So we've got our mass, 55 grams, which is 0.055 kilograms. Okay, just before the student releases the egg, the egg has...
This is his.
Oh, okay. The egg has 8.0 joules of gravitational potential energy. So they're telling us the mass and they're telling us the gravitational potential energy is 8 joules. Okay, so we know our mass, we know our potential energy. How far above the ground is the egg? So they're asking for the height there. They're wanting us to figure out the height. So I'm going to plug the right stuff in the right places. Potential energy is 8 joules. Mass is 0.055 kilograms. Okay, my acceleration due to gravity on Earth is always going to be that 10 meters per second squared. So I'm going to use that as my gravity. And then I'm trying to solve for the height above the ground. So I'm trying to solve for h. Well, 0.55 times 10, I'll just move the decimal point over one. That'll be, sorry, 0.055 times 10 is going to be 0.55. So I'm going to end up with 8 joules equals 0.55 kilograms times meters per second squared times h. And if I'm solving for h, how do I undo multiplying by 0.55? Good, I'm going to divide both sides by 0.55. So I'm going to end up with h is going to be whatever 8 divided by 0.55 is. Well, 8 divided by 0.55, that's going to be 14.5. And since everything was standard for my units, what should be my units for height then? The units for height should be in our standard units for distance, which is meters. Good. So our height should be 14.5 meters. Okay, that's number 3 on the back. Cool. Okay, I'm going to stop there.